We will just wait for 2 minutes more, okay?
Okay, ma'am.
So, hello, little introduction about myself. So, I am Anjali Negi. I am currently pursuing PhD in IIT Kanpur. In Department of Chemistry. So, my research is mainly on theoretical and computational chemistry. Okay, so today I will be solving 3 set of questions of GATE 2014 and one from 2015. And yeah, I'll start the video now.
Hello everyone. In this video, I will be solving GATE 2014 chemistry question number 4. So this question states that the number of C2. Hello everyone. In this video, I will be solving GATE 2014 chemistry question number 4. So this question states that the number of C2Hcs in CCl4 is. So we have to look into the symmetry of the given molecule and find out the number of symmetry elements. For example, the C2 axis, the rotation of axis C2. So first, let's look into some basic. So what is the symmetry and how you can be quantitative? So how you can be quantitative about it, like which one is more symmetric than the other, which molecule, for example, is more symmetric than the other molecule. So these questions will be answered in this video. So I will be discussing it. So the symmetry elements and the symmetry operations. So what are these? So first of all, the symmetry operation. So for symmetry operation is a movement by which any object can go from one configuration to an equivalent or identical configuration. So there is a difference between equivalent, or you can say indistinguishable, and the identical configuration. Okay. So for example, if I take the equilateral triangle, so this is the equilateral triangle, and in this triangle, let's say we denote one side as 1, 2, and 3. So if we do, 1 second. So if I am rotating, okay, rotating my equilateral triangle such that this is the axis of rotation and we are doing a 120-degree rotation. So in such a way that the first, that this point 1 will comes to the point where 3 third was, okay, so this will be 1, 3, 2 now. And again, if I am doing the same 120-degree rotation around this particular axis, so I will get 1, again my 2 will come here. So my 2 will come here, okay, and my 3 will go here, and so this will be the rotation again. But the point to be noted here is that the first configuration and the second configuration and the third configuration, all these are not particularly identical, but they are indistinguishable or they are equivalent to each other. Because what happened here is, if I am not tagging the particular side, so there will be no indistinguishability in between them. So hence they are equivalent. But if I am tagging them, you will know that they are not exactly, they are not exactly the identical like the first structure, okay. So in the last set of rotation, if I am doing the last set of rotation, so this particular equilateral triangle I have not drawn here. So this will be similarly where my 1 from here will go to the position where it was in the starting of the rotation, okay. So it will be 1, 2, and 3. So this will be the identical one with the first configuration, okay. So this is the example with the equilateral triangle. You can understand and apply it to any set of molecule, okay. And so these movement by which I can get indistinguishable structures or even identical structures are called the symmetry operations, okay. So these are the symmetry operations, okay. Now let's move into what are symmetry elements. So when you will see that the symmetry element is some entity within the body. It can be an axis, okay, it can be a point, it can be a plane. So this axis, plane, or point about which a symmetry operations take place and we get an indistinguishable structure is known as the symmetry element. So we have the symmetry element and we do the symmetry operations and we find out the different indistinguishable structures or identical structures we can get. And the more number of identical or indistinguishable structures we get is equivalent to the more symmetry to, in that particular molecule or structure, okay. So example, in previous equilateral triangle example, we have seen that there was a rotational axis, okay. So the element was axis, okay. So if the point here is, if an object or molecule has more number of symmetry element and symmetry operations, then the object or molecule is more symmetric, okay. So among these H2O, ammonia, and the benzene molecule, you will find out that the more number of symmetry operation and element is maximum in benzene, okay. So this you can do by yourself or it's easy. So you will find out that the more number of symmetry operation and element is maximum in the benzene molecule, and hence the benzene one is more symmetric in comparison to ammonia and water molecule, okay. Now what different symmetry element and symmetry operations that a molecule can have? So one can have 5 different symmetry element and can generate several symmetry operations from there, okay. So the first one is the identity one. It is denoted as capital E, and I will simply tell you that it is something which we can say doing nothing or do nothing, because identity is the exactly same configuration that we had in the first or before the operation or after doing the particular operation. So for example, if I just take one example of H2O molecule and tag my hydrogen as 1 and 2, and this is my element which is axis, rotational axis, and this is, for example, if you don't know, so let's just say this will rotate at 180 degree. So what I will get is, I will get the same rotation like a flip, and so okay, so if I'm doing 180 degree, then it will be it will not be the identity. But so if I'm doing the 360 degree, okay, so this will again be 1 and 2, correct? Because if I'm doing 180, then this will be 2 and this will be 1. Okay, so yeah, after this, so this is something which is the same as the first configuration. So we have done only the full flip, or you can say full rotation, not even flip, full rotation. So my molecule, after doing the 360 degree rotation, comes back to the original original configuration, and that's why we have done nothing but so this is the identity, and it is found in every single symmetric molecule. Okay, or when we apply some symmetry operation, if you are doing the identity, it is always present there. So the second one is proper axis of rotation. So I will discuss this up to here only, and the other three I will give you the reference for that, so you can go and take with the detailed notes of that. Okay, so the second one is the proper axis of rotation. So this is denoted as capital C, and in suffix there is a small n, where n is nothing but an order of operation. Now we know the symmetry element here is axis, correct? And the operation that we are doing is something which is called as rotation. Okay, so and the order of operation means n, like 2, 3, 4, 6. You will know that for if I am doing through an axis, say axis C, I am doing a 180 degree rotation of that particular molecule, then it will be n is equal to 2. Okay, and so the order of the operation is 2. For 120 degree rotation that I was doing in a particular equilateral triangle that you have seen, so there I was doing a 120 degree rotation, so my order of operation was n equal to 3. Similarly, for 90 degree and 60 degree, we have n equal to 4 and 6. So in general, the n can be calculated as 360 degree divided by the angle of rotation. So the angle of rotation is, for example, 180 degree. So 360 divided by 180, you will get n is equal to 2, correct? Now, the principal axis of rotation is again Pn, okay? So if you see this example, this is a square with, if I tag 1, 2, 3, 4 to the what you say, edges. Yes, then I am doing, so this is my, so if this is my particular axis, okay, and I am doing the 90 degree rotation. So you are doing a 90 degree rotation means my one will go from here to here, and I can do this 90 degree rotation up to what? Because up to 4. Okay, so n, if I am doing n is equal to up to 4, you can do and get the identity configuration. Okay, after 4 rotation. So my n will be 360 divided by angle of rotation, which will be, angle of rotation is 90. So it will be 4. So my axis of rotation, so this will be denoted as C4. Okay, so this is my principal axis, or you can say axis of rotation is C4 here. Now again, if you will ask me what is C1, because I have not talked about n is equal to 1 order, because in n is equal to 1 order, you are doing a full rotation. So this will be n is equal to 360 by 360. So the angle of rotation is again 360. So that's why you will get the identity E. Okay. Also, you can ask what is C infinite. So if you are asking me about C infinite, so there should be something making n is equal to infinity. So if you see this particular molecule here, okay, so this particular molecule CO2 is a linear molecule, and here if I am drawing this rotational axis along these atom, carbon and two oxygen, you will see that if any number of rotation, I will get the same molecule, or so the order of the rotation for the symmetry element C will axis has become infinite here. Okay, so this will be denoted as C infinite. Okay, and this is highly symmetric molecule. So the molecule can have more than one type of axis of rotation. So there is a point you should note that it should not be in any molecule. It is not particular that it can only have C2 or C4 or C3 rotational axis, but it can have both, or more than one and two axis of rotation. So for example, you can see that this is a triangular planar molecule. So in a triangular planar molecule like this, so this is, for example, let's say this is a plane, okay, and in this plane, horizontal plane, just imagine it as a horizontal plane. I have to draw this plane like this, okay, and the molecule lying on the plane horizontally, and you can see that there are two axes of rotation I have drawn. So one axis of rotation is here, okay, this is the C3. Why this is C3? Because the symmetry will be restored when my n is equal to or in order of 3. Okay, so I will be doing a 120-degree rotation. Okay, and for this particular axis going through my two atom, or you can say one single bond of the molecule, you will have a rotation of what, 180 degree, correct? So this will be C2. Okay, to get the symmetry of the molecule again, or indistinguishable configuration, so it will be C2. Okay, now let's move to our question. So we were given with CCl4. So this is a tetrahedral molecule. So for a tetrahedral molecule, you will see that this is Cl. There are 4 Cl bonds. And before I move into, so there it was asked that the number of C2 axes. Okay, so wait. Yeah, the number of C2 axes in CCl4. This was the question. So, okay. So for C2 axis, my n is equal to 2, and my angle of rotation will be 180 degree. Okay, so my angle of rotation will be 180 degree. So this is my molecule, and you can, so this is tetrahedral structure. It's a little difficult to imagine. So I have drawn it in a cube, and you can now imagine that how my Cl molecules are arranged in a tetrahedral position. So this is my carbon here. Okay. Yeah, this is my carbon here, and these are the 4 Cl molecules. So for this, if I am doing the C2 operation or C2 rotational axis, so it will pass for C2, it should be doing the 180 degree rotation. Okay, so this is the one axis of rotation here. So you can say that for this, like for 180 degree, if I will rotate this, so my structure, so so my structure will be such that after rotation this Cl will be here, correct? This Cl will move here, and again this Cl will move to the position here, and this Cl to here. So this is one axis C2, I will count, and the next one is the one here, okay? So this is again C2 doing the 180-degree rotation. So if I am rotating it like this, for example, okay, so this will move, this Cl, this will move here, okay, and this will move here, and this will come back here. So this will be the again indistinguishable structure for C2, and last axis is here. So you can imagine this particular axis similarly like this one, but from back to the front. I mean from this particular phase to this particular phase, it is doing the 180-degree rotation. Okay. So this Cl will come here, and this Cl will come here, and for these two also. So in total, we have 3 C2 Cs. So in total, we have seen that we have 3 C2 Cs, and so the answer is 3. So the NPTEL reference I will recommend you to go through is lecture number 2 by Professor Manabendra Chandra, Department of Chemistry, IIT Kanpur. Here is the link below. Thank you.
Yes, so you can ask if you have any doubt, or just type in chat box also.
Clear, ma'am.
Okay. So Adbhut. Okay, then I will move to the next one. Okay.
Hello everyone. In this video, I will be solving GATE 2015 chemistry question.
For this particular question, I will ask you to just have the answer in your mind, and then compare the reasons behind each, why this cannot be the particular acceptable wave function. Okay.
Question number 11. So this question states that which one of the following plots represent an acceptable wave function. So we are given with 4 different wave function A, B, C, D. So before moving into the correct option, let's discuss some basic. So for the acceptable wave function, we have following conditions to be satisfied by the wave function for the particular system or particle. So the function must be a single valued function. And the second point is that the function should, when I'm talking about the function, I'm talking about the wave function psi xt, okay? And the function should be normalized. For normalized, it means that the conjugate psi of psi is psi star multiplied with psi should be equal to 1, from minus infinity to infinity, correct? That is, it must have a finite value, and by finite value I mean that for every single value of x, by psi xt should have a single value at particular x, okay? And again, it must be continuous in the given interval. For this, you will see that my wave function should have should be continuous in the given particular interval for it to be the acceptable wave function. The fourth point is that the first derivative must be continuous on the indicated interval. So that when we are talking about the derivative, so derivative of any function is equal to gives me mathematically the tangent at a particular x. So for any given I will discuss it in the next slide also. So for any given wave function, so at any particular value of x, so there should be only one direction or the tangent. So such that the first derivative must be continuous. Okay. So the last one is the boundary condition must be satisfied by the wave function. For our boundary condition, when you will be discussing or studying the case of, like, for example, a particle in a 1D box, you will see that there are set of boundary condition that my particle follows or my wave function follows is such that that at the boundary my wave function is equal to 0. Okay, so those are some boundary condition. So these are the point for my acceptable wave function. So here, uh, so all the four options that we are given with, if I apply the condition, so at for A, you will see that this is not a continuous wave function. Okay, so this is not continuous. For my wave function should be continuous, there is also the physical meaning, because for this particular region where my wave function has no value, or you can say that it has disconnectivity. So at that point, my particle probability of finding of the finding the probability of finding my particle is 0 there. Okay. And for B option, you can see that this is not a single valued function for a particular value of x. So at any value of x, for example here, you will see that we have a different value of psi xt, which is not the condition that we want for our acceptable wave function. Okay. And for C, you will see that this is a continuous wave function, but here the first derivative is not continuous, because at any peak point or any sharp point, you will see that we have the derivative of this function is not continuous. So here we have different direction of our tangents, and therefore this wave function is also not acceptable. For D, you will see that the wave function follow all the condition, and hence it is the acceptable wave function among the all different options we are given with. Okay. So this is a correct option. And here I am attaching the NPTEL reference for lecture number 4, Postulates Part 1 by Professor K.S. Sebastian, Department of Chemistry, IISc, Bangalore. Here is the link below. Thank you.
So any doubt? Okay. I will move to the next question.
Hello everyone. In this video, I will be solving Hello everyone. In this video, I will be solving GATE 2014 Chemistry question number 43. This question states that MnCr2O4 complex is. We are given with 4 different options. So we have to find out whether this particular complex is normal spinal or inverse spinal, and we have to find out the CFSE, that is the crystal field splitting energy of the given complex in the unit of TQ. Okay, so let's move into some basic. So spinal structure is a series of compound having combination of two oxide So it is a mixed oxide of divalent and trivalent metal ion. Okay. By saying divalent, that is A plus 2, it will form oxide AO, and a trivalent metal ion like B plus 3 will form oxide B2O O3. So my spinel will be AB2O4. Okay. Now there exists two type of spinel. One normal spinel and other one is the inverse spinel. So for normal spinel, the spinel structure is such that the oxide ions are arranged in CCP is such that oxide ions are arranged in cubic close packing CCP, and divalent ion is present in 1/8 of tetrahedral void and the trivalent ion is present in half of octahedral void. Okay, so this is the normal spinel. We can write it as this A, which is a divalent. It is present in tetrahedral void. B, which is the trivalent metal ion, present in octahedral void with O-force. Similarly, in inverse spinal, so in inverse spinal, what will be my trivalent ion gets distributed equally among octahedral and tetrahedral void, okay, and my divalent metal ion, that is A, is occupy the octahedral void, okay. So here my trivalent ion is equally distributed between tetrahedral and octahedral void. Okay. So to distinguish between these two, to identify the spinel, we take the help of crystal field splitting energy, that is CFSE. So we calculate the CFSE of both the metal ion, that is divalent and trivalent, and then compare these two such that if my B plus 3 CFSE in octahedral field, if it is greater than the CFSE of A plus 2, it will be a normal spinel. So similarly, if the CFSE of my trivalent metal ion is less than the CFSE crystal field splitting energy of my divalent metal ion, then it will be a inverse spinel. Okay. Let's just note some tips. Number one, that the CFSE of a non-transition metal is 0. And number two, if both A plus 2 and B plus 3 metal ion are non-transition metals, then they belong to normal spinel. Okay. Now, talking about the crystal field splitting energy, CFSE, in octahedral field. Here, because it is a oxide, mixed oxide, so we have a weak field complex. It will be a high spin complex. So our metal will experience, it will be a high spin complex or a weak field complex due to the weak field ligand. And since my O4 occupied the CCP structure, that is why it is a octahedral field. So the splitting energy for the octahedral field for D, it will be something, it will be like so the splitting energy for D orbital in octahedral field is this is DG, this is D2G, this is D orbital, this is my energy. So this is D XY, DYZ, D ZX, and this is D X square minus Y square and D Z square. Okay, and the energy is this is 0.4 minus 0.4 del naught, and this is plus 0.6 del naught. Okay, so we are given with the complex MnCr2O4 where my divalent cation Mn2 plus having electronic configuration 3d5, okay, and my chromium plus 3 having electronic configuration 3d3, correct? Now as this is a octahedral complex, so the crystal field splitting for the octahedral complex as we have seen. So in Mn plus 2, so in Mn plus 2, we will have the CFSE equal to 0, and in Mn in chromium, you have the CFSE equal to, so I can just show you here quickly that in octahedral splitting, okay, so this will be this will be 0.4 okay, and for D3 configuration it will be 1, 2, 3, and my CFSE for chromium will be 3 into minus 0.4 del Q, which is minus 1.2 del Q, okay, and similarly my CFSE here is 0 because you can see in electronic configuration after splitting of orbital, so my electronic configuration is 3d5, so it will be okay, so this will become 3 into minus 0.4 plus 2 into 0.6, so this will become 0, correct? So this is for Mn plus 2 and this is for chromium plus 3. Now what happened is we have a CFSE here as minus 1.2 delta naught, and I can convert this delta naught crystal phase splitting energy into dq by just simply multiplying it with 10. So it will again be 0, and this will be, if you multiply it by 10, it will be 12 dq. Correct? Now, okay. So here, for my MnCr2O4 complex, okay, for this particular complex, as we have seen that the CFSE for chromium plus 3, that the trivalent is more than the CFSE of the divalent. So this is a normal spinel, okay. Spinel, we say it's spinel. So this is a normal spinel, and yes, so the total CFSE that we will calculate is will be, so for manganese it is 0, okay, and since we have 2 Cr, so it will be 2 multiplied with minus 12 dq, so we will get minus of 24 dq, correct? So for this particular complex, it's a normal spinner, and we have a CFSE of minus 24 dq. So this is the correct option, and I will recommend you to go through the NPTEL reference lecture number 48, perovskite and spinels, and by Professor Madhav Ranganathan, Department of Chemistry, IIT Kanpur. Here is the link below. Thank you.
So yes, if you have any doubt, you both can ask. Okay, also if you have any feedback, because it has been 8 weeks completed today, so yes, I think 8 live lectures, and another 4 will be there, so you guys can give your feedback too. So Adbut has joined my live lecture for I think for the first time today, and Gunasli, you have joined earlier also, so you both can give your feedback. It will be nice. So Adbut, you are a student right now?
Yes, ma'am.
Okay, and you have completed your master's or pursuing your
No, ma'am. I'm in the final year of masters.
in your final year? Okay, so from where you
Yes,
are
ma'am.
doing your master?
I'm from Surat.
Okay, from Surat. Okay, good.
Yes, ma'am.
So you got to know about this live series. You have attended. I mean, for the first time you are attending mine. So you have gone with others also.
No, ma'am, not for the first time. I have attended your other series also,
Okay.
but I was not regular in other classes or lectures.
Okay.
Ma'am, I think the only feedback, the one thing I'm missing, I'm missing in this series, ma'am, that apart from solving the questions, we can also have some discussions about important topics in the chapters,
Oh yes.
which is the more.
Yes. Actually, in the starting of the live series, so we were asked about if we only have to solve the questions and discuss about the problem regarding that, but also I have also offered if you want any topic to be, but for that you have to be present in the next live series, because what happens is that someone asks something to give a tutorial about it, and then if they are not present, then it's not good. So if you are
Okay.
suggesting some topic to be discussed, then you can type, or you can just tell me right now.
Oh, yes, ma'am. Ma'am, actually, your lecture is once a week. It comes in every Sunday on only once a week.
Yes, yes.
So ma'am, sometimes I don't remember, or sometimes I don't get
Notification.
notifications or that.
I think you can get the notification by subscribing it, something like that, because I'm not sure how they are promoting the live series, because we are told to have one slot, so we are doing it voluntarily. So actually, yeah, I'm also doing my PhD, so I have to give 2-3 days to this and make videos and be present in the one slot every day, every week. So so no problem. We all, I think 8 week lecture is completed for each of us. So after that, I think there will be 4 more, because it's a 12-week course. So you can tell me the topics and all, so I can also float with my other fellow mates. So if they are also interested, they can update in the that what a page where you can see that what topics will be covered in the upcoming. There is a page, right? So you can see that what are the actual broad area or topic they will be covering in their live session.
Yes, ma'am. Ma'am, recently I have some problems in the magnetic moment, or determining the magnetic moments of the
Magnetic
okay,
moment, like in coordination chemistry.
in coordination. Ma'am. Yes.
Okay, wait, I will just write it down. So you have problem, or like problems of solving the magnetic problem questions.
Yes, ma'am. Actually, I have some.
And you want
I have
some
not.
basic to be clear, right?
Yes, ma'am.
Mm-hmm.
There are various formulas, ma'am. Actually, I don't get.
Okay, okay. So in coordination chemistry, dipole moment or magnetic moment, right?
Yes, ma'am. That is very good history.
And what else?
Ma'am, in coordination, the only magnetic moment is there. And ma'am, yes, this spectrochemical, the spectrometry, the spectroscopical, there are some techniques in which, ma'am, the mass spectrometer.
Yes, yes.
Um,
I think
uh,
mass, NMR, all these which you get the problem to solve in GATE exams. This you can, if you have attended the live session of organic people, because I'm from physical background, so I can actually have some, I mean, topic clear, but if it will be much better if they will be teaching you all these instrumental techniques. So do you have that link? Because there is a link, gate portal, and
yes, ma'am. Yes, yes,
you
ma'am. I
can
have.
check whose live session will be there, what slot, and what there is a because we have updated all, like up to till today we have updated, like what broad topic we will be covering, correct? So
Yes, ma'am.
some of the organic people have also covered the topics from GATE previous year, and you can. So okay. So just give me your feedback. I will pass on your information to them also. If they are interested, they can do this in their live session. So you are saying about the instrumental technique.
Yes, ma'am. Instrumental techniques. So most of the time we just go into the questions and directly try to solve it. But some basic concepts, yeah, although we know, but still, the concepts. where we lack, ma'am. But the mentor just we try to solve the questions.
So like mass spectrometer
Yes, ma'am. And then there is
and
NMR.
NMR is there, yes.
In today's lecture,
Yes.
there was initially when I joined, there was we were discussing the questions of group theory. Some questions.
Yeah, so it was a question about CCl4 molecule and the number of C2 axis is present in CCl4. So I was covering, the way I make video is that whatever is asked in the question, I just try to give some basic before and then up to only that, because if I will be giving all the, because there were 5 symmetry elements, correct? So if I will be discussing all 5, then it will be a very long video. So what I do is I cover up to the one which is asked in the question and then I'll solve the question. So yes, what is your doubt?
In group theory, ma'am, there are some questions regarding the improper axis of symmetry.
Okay, so in
And
group theory,
yes, ma'am.
you want the improper axis of rotation to be clear, okay?
Yes, ma'am. The concepts about this, and it would be better if you show some questions about this.
Okay, yes.
So, on the next Sunday, we will be covering this topic.
Okay, wait, someone has just joined. I don't know. Pranoy Kumar, you just joined in the last 1 minute. I don't know. Yes, so Adbut, yeah, what else?
And I was asking, will you be covering this topic in the next?
Yeah, sure. I will cover the magnetic property, magnetic moment question from coordination chemistry, the basic and the problem. And for instrumental technique from mass spectrometer, NMR, their analysis and all the topic, I will pass the information because we have one group. I will pass the information to the organic people. And group theory I will see, because I also have to show you the gate problems, right? So I will play all 2 or 3 videos in the live session, and in the remaining time I will discuss one part of the coordination chemistry you have asked. Okay.
Yes.
So it will be again in the next Sunday. Timing is 3 to 4.
Yes.
And I will suggest both of you, Gunasli also, if you have any topic you want to be covered other than the solving just the problem, you can ask not only me and give your feedback to the other to whosoever live session you guys attend, because many of the students will love to do this. Okay, so you can give their feedback to them also. Okay, anything else?
No, ma'am.
Okay.
Thank you, ma'am.
Yeah, so
Thank you.
the way I made the video was okay with you, or you want more basic?
No, ma'am. The explanations are good.
Okay.
We can easily understand while explaining the questions.
Okay, thank you. I will pass the information. We'll meet on the next Sunday, okay? Yeah, thank you. You can leave.
Thank you.